Alright, sorry about that, guys. For those of you on the recording, you're going to have to just deal with not being able to see the browser. I apologize. So we covered variables. Methods are, so variables are kind of how an object can know things. We haven't necessarily covered exactly how to put them on an object yet, but we'll get there later. Right now I'm just kind of teaching you the basic constructs, and then we'll get more into objects. And methods are surprisingly slow. Come on. Come on.
You still can collect. I cannot collect.
Oh, did we lose connection? Is this the thing that happened? Oh, well, I guess I am still connected. Okay. And then so we have variables and then methods. You can tell methods because they'll often end with parentheses, because that's how you call a method. And you define a method kind of like, well, not kind of, you define a method like this, where you have some sort of scope, private, public, protected. We'll cover that later. I just did static for this. We're not there yet. This is why Java is really hard to teach. And then a method may output some sort of data. You have to declare what type of data you want to output, just like you have to declare the type of a variable, same thing. So the type of data that the method will output, if it's not outputting any data, you use void. And then the name of the method, and then the inputs, okay? And the order matters, right? So, do good on time. So in this case, we're accepting two inputs, an integer a that we're going to call a, and an integer that we're going to call b. And then in this case, we're just going to return a plus b. When you return, that ends the method. And if there's a value after it, that is the output of the method. Whatever type of data this is must match the type that the method outputs. Otherwise, Java will complain at you. It's be like, hey, you're lying to me. Don't do that. So then, as you can see up here, we have add with output, and you'll see that we're giving an x. We can give an x because it's an integer, and then we're giving it 4. 4 is an integer, and then we get the sum out, which this prints out if x is 5, and we're giving 4, and this returns the sum of the two inputs. What is sum going to be set to? 9. Yes, cool. So that is methods in a very, very, very fast manner. We can do that. You can also not provide output. This won't actually do anything though, because it takes the inputs and then doesn't provide any outputs. So this method is actually useless. But it's a good way to kind of demonstrate things. Whoa, too much, too far. What did I do? Oh, that's right, I made it edit earlier. This is terribly difficult to... And the internet is really slow. So that is how to write some Java code. I told you about the compiling and running already. So that was more or less the material we covered last week, very quickly. Does anyone have any questions? No, that was very fast. Okay. Good. Good. Does this, for people who were here last week, does this sound familiar? Or have you forgotten everything over the past week?
Sounds like new stuff.
Oh, it sounds like new stuff? Do you want to spend more time reviewing it? Okay. Okay. So today we're going to move on to conditions and loops. These two are some of the more difficult concepts starting out. Conditions, not so much. Loops, people tend to find difficult when they're just starting out. So this might be a little painful. So if anything doesn't make sense, you need to ask me immediately, because everything's going to build on each other, and if something doesn't make sense and we keep going, you're going to be really confused. Okay? So feel free to interrupt me, ask questions. Please interrupt me. It's not rude. Just let me know. Okay? So first I'm going to make a new directory because it's also much cleaner. Okay. So in your text editor choice, whether it's Atom or Sublime or Notepad or TextEdit or whatever you're using, go ahead and create a new file, and let's call it conditions.java. I don't know if you can really see that. It says conditions. Call it this. Is this big enough? Can you guys read this? You can read this? Okay. So name the file this. And we're going to do this guy. Again, this is, if you remember from last time, we're just going to kind of copy the boilerplate code we had. So, public static void main string args. You can just copy this. The farther along we get, the more sense this will make. And Charlie, if you feel that there's anything that needs clarification and I'm not clarifying, or if I say anything flat out wrong, please interrupt me.
No problem with that.
Cool, perfect. Are you using Atom? Good question. Is there... Cause static. Right. So what you want to do is you want to make sure to save your file with a .java extension. Yeah, so save it, because then Atom will recognize that you're writing in Java, and it'll do the coloring. And you get that? So copy this up here. Okay, so yeah, so just select Notepad tonight, unless you have Atom installed. Right. Okay, so just use Notepad. No, Notepad. WordPad will look things up. You good? Okay, so you're good. Cool. Are you guys okay? Can tell now? And you basically want to copy what's in here.
Yeah.
This is kind of your boiler, your base code. So I should be using English metaphors. You'll pretty much always start with something like this when you're running a command line application. Or really, pretty much always. You'll just be changing whatever this is.
Have you been able to connect to the internet without the app?
Sorry?
Do you have that coming to you open with?
Did you install Atom? Okay, none of us have it on the, yeah. So, is everyone up to this point? Yes? You're up to here? Okay, cool. So, let's go ahead and declare a variable called x. Let's go ahead and set it to 5. And conditions are actually pretty easy. Loops are the ones that'll be a pain. Computers are really good at logic, right? So if you say if this, then that, computers are really good at it. So good at it that we have language in programming languages specifically for that. So the way that it can, when we say a condition, it means that if some state of the world is true, go ahead and execute some logic. That is what a condition is. So in effectively all, I might be shooting myself in the foot by saying that, but effectively all languages have some sort of condition construct, right? In Java, it's called an if statement, or at least that's the most common one. There's a couple others too that we'll cover, but to start with, if. So you do if, and then some condition, hello, and if whatever is at the beginning of it evaluates to true, like 5 is greater than 4, if that's true, then the body of statements inside that block will execute. If the statement is not true, it will not execute. Again, very, very simple. So let us know when your laptop is, or let me know when your laptop is set up, and I'll get you caught up, okay? Okay. You got her? Thank you, Charlie. So a condition looks like this. Again, if we can say x greater than 4, why is this not doing the fancy stuff? Also make sure that this is not messed up. No. Yes. And this. Okay. Sorry guys. Good enough. So, what will happen when we run this program? Cool. Does everyone agree with that? Does anyone? Now, what if I were to do this? Well, if I were to do this, what would happen? Yes. But you two can't answer the next question. No, that's a trick question. I don't want to do that. So let's go ahead and prove that. All right. So let me go ahead and go into my Java directory, and then we're going to compile this file, conditions.java. Right, and then you'll see that class file showed up right here. I don't know if you can really see it, but that JavaC created the new file. And then if you do conditions, x is greater than 4. Big surprise, right? Is anyone confused? You guys with me? Okay. Now, if I were to change this to a less than, nope, except I should use the correct file. Let's also do this. Whoa, hello. There we go. Let's also just close this because I'm not. Just like was mentioned, because 5 is not greater than 4, and there's no other output that this program is doing, nothing happens. Okay? Now, here's something very, very, very confusing. This is important. Okay? This is not what you want. This will make you sad. If you do an equal sign, can I make this even bigger? Because I see you squinting back there. How do I... Atom? Yeah, you need it, right? Editor. Yes.
SDK already downloaded?
Yeah, it's on that USB stick. 32?
Yeah, 32 or version 32.
Wow. Okay. One of us would have to download it. Okay, so is that better? Oh, that's right. Thank you. And let's turn on word wrap. There we go. How's the recording? Better. Sorry guys, I gotta make sure that the recording is good because we do have a number of people who... Okay, there we go. Good enough, I guess. Okay, this right here is not what you want. In Java, a single equal sign means assignment. Assign this value to this variable. And that only means that. In Java, if you want to check if something is equal to something else, if you want to do an equals comparison, you want to do double equals. Okay? Be very careful with that, otherwise you'll spend a lot of time being like, why isn't this working? Double equals is the comparison operator. Okay? Good question. If greater equal to is that, less than or equal to is that. Also, not equal to is that. Okay? So this will also output nothing. This will say that x is greater than 4. This will output nothing. And this will output x is greater than 4. So far so good? So to get you caught up a little bit, this part you can pretty much always just copy. Okay, he's got you. All right. So that is basic comparisons. Now we can go a little farther than this. You can chain logic, right? So let's say we wanted to do something where if x is not greater than 4, but it does meet some other condition, there is a construct for that too. You can say else if. Whoops. And then this will only cause the next body of logic to execute if this is not true and this is true. Okay? Good question. When it comes to this, anything in quotes is text as data. Doesn't matter. It's whatever you want it to be. Everywhere else, it is 100% important. It must be exact. Otherwise, Java will be confused. System with a capital S is the system library in Java. System with a lowercase s, Java has no idea what that is, and it will complain at you. A little bit, yeah. Yeah. So. Are you two doing okay back there? Okay. Do you want me to slow down a little bit? Okay. So yeah, the nice part is that you can continue chaining this. You can do as many if-elses as you want. So you can say x is less than 4. Whoa. Jeez, I cannot type today. That will do the same thing, right? Now, there's one other part, there's one last part of if conditions. There is else, just a simple else. We've done else if, but there's also a pure else. With a pure else, this body of code only executes when none of the previous statements within this chain are true. Okay? So, if this is not true, and this is not true, and this is not true, then this will execute. Okay? Oh, yes there does. Thank you. Good eye. Semicolons are important. You need them after every statement. So now if we were to run this, I'm just making sure that I didn't have any typos. Again, x is 5, so x is greater than 4. Okay? Now, if I set x to 20, sorry, if I set x to negative 100, which of these is going to execute? Tell me the line number that's going to execute. Yep. Line, yep. Line 10 will execute. Hey Rob. Good to see you. No, it's fine. We reviewed, and now we're almost done with conditions, but conditions are easy. So, well, in comparison to some of the other things we're going to do today. All right. So, here's a trick. Are you ready for this? What will this program print out if x is negative 100? Sorry? Yeah, which text will it print out? So, keep going, you're almost there. Let me read it again. Look at so let's review the conditions. So if x is negative 100, is this condition met? Okay. Is this condition met? Is this condition met? It's going to stop here. It's not going to continue. So this will only run. Huh? Yes, correct. This will only run because of this else right here. This will only run if none of the preceding ones are true. Yes. Within the same block. A block is defined as, in this case, starting with an if. Okay? So this starts a sequence. Okay? So let's go ahead and just prove that. Ooh. Oh, whoops. Again, same thing. Because this is not true, this is not true, this is true, and then it quits. Okay? Now, I'm just going to be lazy. Now that I've added this, what will be printed out? Now that I have added this, what will be printed out? X is less than 4? Cool. Will anything else be printed out?
If is another condition, so also.
Hey, yes. Yes. That is correct. All of these things are killing me. No, no, I don't care. Go away. Okay, there we go. Because this is a separate block. We know that it's a separate block because it starts with if. Okay? So this will run as one sequence, and this will run as a second sequence. They're distinct from one another. Okay? Any questions so far? Is she okay? Okay, cool. Everyone good? Alright. Now, that's one type of condition. There's a second type of condition in Java. Forget it? Yeah, that's right. It works fine with primitives. It's called a switch. So, a switch, or it's called a switch case. A switch case takes one value and it checks a bunch of conditions. Okay? Now, in the if statement, each of these segments is exclusive, right? Only one of them can execute. In a case, they allow what's called fall through, where if the first case is true and the I never use case, so I have to remember. If the first case is true and the second case is true, both of them execute. Does it start and then continue? We're going to have to experiment because I don't remember. Right, but I forget if you have your first case and your first case is true and there's no break, and you have your second case, does your second case also have to be true, or will it continue?
No break, keep going.
Regardless of whether the second condition is true or not. Okay, that's what I thought. Thank you. So we can switch on x, and then we can say in the case that x is 10, do something. I'm also going to put this online. So, yeah. Then you can say actually, I'm going to add a case here just to be a little clearer with the output. What will be printed out here? In this case, x is negative 100. Because the way that it's going to work is it's going to take the value x, and then it's going to look at each of these cases. And it's going to go, is x equal to 10? Yes or no? No. X is negative 100. We have it set to... Yeah, we have it set to negative 100. Yeah, and switches a condition.
From the main,
Yeah. Yeah, x is... We have not changed x. So x is 10? No. So we're going to go to the next. X is 20? No. So we're going to go to the next. X is 100? Yes. We're going to run this. Okay? Can you see back there? Now, case is really useful because this is a lot less text than that if statement, right? But it behaves differently. Okay? If I take this case and I move it up here, case will continue to run until you tell it not to. Okay? So everything within these will run from the point that it starts until you either tell it to stop or it reaches the end. Okay? Let me demonstrate. This is why switches can be confusing. Once it meets the first good condition, it keeps running. Okay? It could be useful, yes. Now, what if you don't want it to do that? What if you want it to stop? There's a keyword called break. And that breaks you out of the current context. Okay? So this is the context we're in. If this line executes, we get out. Okay? Does this make sense? What if I were to move the break to here?
X is lesser than 4, X is minus 100, case X is minus 100, case N is, case X is.
Correct. Let's just demonstrate. Correct. Okay. Now, there's one more keyword for case. Whoa. It's called default. Default is kind of like the else from the if. If none of these are true, this will run. So let's say we change this to -101. Oh, and let's add the breaks in there. Well, no, that should be fine. It's because of this default right here. Because it's not -101, it's not 10, it's not 20, so it's going to go to the default. So far, so good? Default runs when none of the cases are true. Think of it as the default behavior when none of the special cases have been met. So it's not -101. That's no good. It's not 10. It's not 20. Then we're going to default. Okay? Questions?
It's difficult to run for offline. Right.
Oh, if it were higher? I don't actually know if that works. I don't think it does. Pretty sure.
I never done one.
Yeah. I don't know. Yeah. It compiles.
It's true. Sorry. Does it show the default code?
Right. Yeah. So then, what if we put it in the middle? I wanna try something. So that's a really, yeah, like you said, that's a good question. I hate case because it's really hard to read. I'm gonna add a new line.
It depends on who you write.
Right.
I like PDX.
Yeah.
I like cases better. More concise.
Yeah, a lot less stuff. Yeah. Okay, so I'm gonna... Let's just try this. Why am I keeping typing this? I have up. Okay, so now what if... Sorry, I'm experimenting at this point. Interesting. Okay. So yes, it behaves how you would expect. Yeah. So yes, it does do that. It doesn't make sense to put defaults anywhere except the end, because then whatever that last case is won't happen. Because default looks at all the previous cases, and so if none of them are met, it's going to run there. If you have a case after that, unless you want fall through, like it's not going to run. Or if you don't break, it will run. But yeah, does that make sense? Yeah. Is anyone? This one's kind of confusing. Does anyone? I see that you look kind of puzzled.
Yeah.
So default just checks if any of the previous conditions have been met. If they have not been met, default runs. If you put default at the very top, there are no previous conditions, so it's just going to run. And it follows the break rules just like everything else. So I'm going to change this back because any questions so far? So, little pop quiz. What keyword does an if condition start with?
What?
What keyword? Yes, if. In the if construct, what's the keyword for when no previous condition has run? Yes. If I want to, now neither of you can answer this next one. If I want to run one condition, but only when none of the previous ones have run, what two words do I use? Louder. Else if. Yes. Okay. In a switch case, if I want to, what is it called when you have one condition true, but then it continues running? Sorry, let me restate that. That was not clear. In a switch case, what is it called when you have one condition true, you have a second condition, and it just keeps running through? Maybe I did not emphasize that enough. When you don't have a break statement. Okay, I didn't emphasize that enough. It's called fall through. Because you have one condition, and if you don't break, it falls through into the next one. And it's just going to keep falling until you break, or it ends. Okay? In a switch case, what is the key word? What is the key condition What is the key word for the condition where none of the other conditions are true? Yes. Cool. So you guys get it. In a condition, in an if statement, what do I type when I want to check if one value is equal to another? Yes, two equal signs. Two equal signs. What if I want to check if one value is greater than or equal to another value? These are silly questions, but I have to ask. Yeah, greater than equal to. So, like that. Okay. Actually, let's actually just for because I plan on posting this up later, so I want to make sure everything makes sense. Everything is demonstrated. Cool. Excellent. So that covers conditions for the most part. Next we're going to go, perfect. Next we're going to go into loops. Now loops are a little confusing because they involve conditions.
So is there only used for numbers?
That's a really good question. No, you can use them for anything. So what we can do, but they may not always make sense with anything. So if we were to have, let's say we have a string, right? For those who have not been here before, a string is what you call text in Java. An individual symbol is called a character. When you have multiple characters together, it's a string of characters. So we call it a string. String text equals hello. Does that make sense? However, things get kind of funky when you do something like this. Like that. Exactly. I'm not actually sure what this will, I don't, see, I have no idea what this would do because I never do this because it doesn't make sense. Yeah. So, Java 8 though, right? So, but integer isn't an object though, it's a primitive. So how does it know?
Each character has its own integer value, so we may compare the...
That's right, because string is an object, it looks for comparable. Yeah, that's too much.
For string, when you compare string, you still like use double equal signs.
Right.
He's not a very string numbers.
So only one?
Yeah. That brings me into a whole nother thing that I never covered with conditions, which is really important. So I'm pretty sure equals is for, really? Man, I hate Windows command line. Huh? So, string has a special method called equals. Okay? It checks if the value that's being called on is equal to whatever's passed in. Okay? And this returns a Boolean. For those who were here last week, you should know what a Boolean is, true or false. For those of you who are new, in Java, there's a data type called a Boolean. spelled like that. It looks like that. Okay.
Small case.
Sorry? Oh, is it? You're right, thank you. Sorry, Python. Too much Python. Yes, so thank you. Case does matter. It is lowercase. I made a mistake. Now, funny thing. These, they're not magic. This is an operation. And this returns a value. That value is either true or false. Right? So when we're thinking about it normally, we don't really worry about this. But what this is actually doing is it's doing a calculation. And it's returning a Boolean that is either true or false. Okay? So if really only accepts true or false. Okay? It's just that this evaluates to, in this case, true. This returns a Boolean, true or false. Okay? So that's why this works. Anything, you can also do something like this. Because true is always true. That's right, we don't want to cover that other part yet. So yeah, any questions about Booleans, true, false? Are you talking like that? Or are you saying like this? So this will never run. Remember when we did not equals? Not you can use anywhere. So you can say not true. Because the exclamation point is not. So if it's not true, what is it? And if this is false, will this run? No, because if this is false, this will not run. This must be true. Whether it's something like this or something like this, they output true or false. If only accepts truth. Okay? Good?
Yeah.
Cool. People don't look super confused. Maybe a little bit of confusion. Are you good?
Yeah, so the not equals means right?
Yes. Yeah. So the output it produces is a Boolean. Yes. Yeah. Yeah. So. Yeah. So yeah. So if I wanted to say, here we go. Good question. I'll just leave it at that. Which doesn't make sense, right? Should I move this higher on the screen so you guys can see? There we go. Oh, really, Adam? Come on. Is everyone good so far? Cool. Anything else with conditions? We covered switch grab case. We covered booleans. We covered evaluation of booleans. We covered the different operands. This is important. All of these examples I've been showing you have been value, comparison, value. Anything can be inside an if, as long as it ends up as Boolean. So we can do something like, and this sounds silly, but I have to cover it. We can do something like this. Let's not do quite that big. That doesn't make any sense. Let's do that. This, even though this is madness, it's totally valid. So as long as what's ever in here evaluates to true or false, in this case, thanks to the great event sign, it'll behave as expected. Okay? So now, that's not to say that you want to have like your whole program in a condition, because there are people who do that because they're mean. But you'll, as you get more practice, you'll be like, hey, maybe I should take this operation and put it in some other variable, and then just check that variable. Like, you want to balance efficiency with readability, as I've mentioned a couple times in the past. Like, if I saw this in actual code, I'd be mad. I'd be like, dude, not necessary. Just toss in another variable. It takes up 32 bits on the stack. Who cares? Yeah. Cool. Any questions about conditions, or is everyone comfortable? No questions? Cool. All right, so let's move on to loops. So let's go ahead and create a new file. If you need the boilerplate code, here it is. We have this till, so we have another 45 minutes, right at the midpoint. Perfect. You want to do more versional offers? Yeah, let's do that first. Okay. Has everyone got their boilerplate code down? Yes? Yes? Cool. So we'll cover the theory, and then we'll start writing some code. So, in Java, and in most languages, there are two kinds of loops. There are for loops, and there are while loops. Okay? First, a while loop. A while loop is really simple. A while loop takes in one condition, and then as long as that condition is true, it will run whatever code is inside it until eternity. Until either the program forcibly stops, or something makes that condition not true. Okay? A for loop is much more complicated, and I'll cover it after we do a while loop. Okay? So the way a while loop looks like, you do while, and then parentheses. Okay, kind of similar to an if statement, right? Now, what I'm about to do, don't run this, because I don't remember how Java handles it. is it not doing stall trap? There we go.
No end.
Sir?
You don't put the end.
One more time?
Oh, nothing. Just loop it continuously.
Yes.
Okay.
So don't run this. I forget. I don't remember if Java will actually let me run this or not. Let me pull up my task manager just in case. Okay. So let me also make this so that you can see it.
Why?
It is printing forever. And it will keep printing. And it will keep printing and it will keep printing. Because there's nothing that can make this condition false. So, be very careful. Be very, very, very careful with while loops. Otherwise you might have a bad time. But they can be really useful. Whoa. Took a little effort there. We can make them a little bit more useful. For those of you who haven't seen this before, this /* is a multi-line comment. It's a good way to make code not execute. We'll start with that and then I'll... Oh man, that is all sorts of... There we go. Okay. I'm gonna wait till people stop typing. That's a little easier for folks in the back. So, what is this going to output? Take your time. It's going to take a minute. Okay. So, while this remains true, this will keep running. So, when would this stop being true? Correct. So then, with this logic, when we're printing out what x is, and then each time we're increasing x by 1, what is this going to output? 0, 1, 2, 3, 4. Because we start at 0, and then the loop says, is x less than 5? Right now x is 0, so yes. So we're going to run. It's going to print out what x is.
No, it will print out 5, I think.
Okay. No. X is initially set to 0. Is 0 less than 5? Yes. So then this will run. So this runs one time. X is 0. And then we increase x by 1. And then it goes back to the beginning of the loop. This is why it is called the loop. Now, what is x equal to after this line is run? If it was 0, what is it now? 1. Is 1 less than 5? And you get the gist at this point, right? Cool. Now this sort of operation is actually really common. There's a simpler way to write it. You can just do that. It means the same thing. You can do that too. So I'm going to use equivalent to. Yeah. Cool. That way you guys can see. This is the same as this. Is the same as this. Okay? Makes sense? It's just a nice little shortcut. You can also do minus minus. Yeah. Yeah. Questions so far? Does a while loop make sense? Cool. Just like a condition, this is anything that evaluates to true or false. Yeah. So we could do something like let me do, sorry, my bad. I did that backwards. Yeah, just random letters, doesn't matter. It could have been XXXXX. Oh. Vietnamita. Yeah, it's slang. It's the, but duh.
How about trop?
Truth. I was being silly. Sorry. Yeah. Let me. There we go. Sorry. Who is feeling really bold and wants to explain what this will do? I know you get it. I know at least one of you gets it. There's a little bit. Sorry? So what can you explain to me the sequence of events that happens? Yes. Okay. Yes. Sorry, I misunderstood what you said. When she started talking, I was like, yes, that's it. So, yes, you're both correct. Majayo, right? I'm learning. So the first time it runs, text is not modified. So it prints nothing, because it's empty. So nothing. Okay. second time it runs, it has added 1 O. So when it comes to the next time, go ahead and print 1 O. Now because this happens at the end of the loop, so we modify this, and then we check the condition, and we're not running when it's 4.
Gotcha.
Yes.
Okay.
So after the third one, when it runs the third time around, we add the 4th O, and then, well now, that text equals 4 O's, so we're not going to run. Make sense? Cool.
Can you use that one in actual programming?
No. Absolutely not. This is terrible. I'm just making a point. Don't do this.
You're good.
Okay. Any questions? Cool. Now we're going to do for loops, because that's all while loops are. It runs until it's not supposed to. It's very simple. For loops can be much more common. I forgot to research something. The Java A construct of the for in. I'll have to remember that later, but that's afterwards. So, I forgot something. Actually, that'll be good for next time. Or no. Okay, so for loops. So a for loop is a little more complicated. It is... I'm just going to show you. So a for loop consists of 3 steps. Your initialization step, and you set your start point. Your termination condition, your endpoint, and your incremental step, what it does at the end of the loop. Okay? So you can kind of write a for loop by using a while loop. That's kind of what we did. Whereas this is our initialization. This is our termination. Or rather, not termination, but our allowance is probably a better way to put it. And then this is our incrementing step. A for loop is all of these combined into one. So you can do and then all of these 3 lines of code that we had to write are just combined into one. It's just kind of a shortcut. So let's...
For loop is more useful than just loop, because in the real world, you're telling one. So you don't have to
that's debatable. So I specifically use those kinds of examples with a while loop to make explaining a for loop easier. You could do things like, this isn't the greatest example, but I'll try it anyway. Let's say that you were writing some Java application, and you needed to connect to some other service. And you absolutely needed to connect to some other service. And you just wanted it to keep trying over and over until it did. You could have your connected thing be like, while it's not connected, keep trying to connect. And then whenever it happens to connect, then that condition will cease to be true and it'll continue. that specific example would actually not be very safe, but it's the right idea. So does that answer your question?
Yes.
Cool. Does the for loop make sense to everyone?
Yes.
Like once you've explained while in a certain way, for loop is not anything super crazy. However, we can do for loops backwards. Actually, can anyone tell me what this will print? Oh. Ooh. Actually, yeah, someone tell me what this will print. It's kind of a trick, because I made a mistake.
Nothing.
Correct. Because I made a mistake. You are absolutely correct. So it starts with I as 0, and then it checks if I is greater than 0. Is 0 greater than 0?
No.
So will this run?
Nothing.
Correct. There is nothing about I. Doesn't run even once. So yeah. How about if I do that? That's what I meant to do. Yeah, also. Can someone tell me what this will print? Someone that's not Kate, because I'm pretty sure she's got it figured out already. Correct. Including one or excluding one?
Including one.
맞아요. 잘했어요. There we go. 참 잘했어요. Is that very well done? Or?
처음 잘했어요 for your elementary kids.
Oh.
처음 잘했어요.
Oh, okay. Then 잘했어요, because you're our well past elementary kids. Though I have taught elementary kids this stuff before. It's cool, yeah. They get so excited, but we'll talk about it later. Can someone explain to me the sequence of events that's happening here?
It starts at 10, decreases by 1 until 1.
Correct. So this is the initial condition. This is the initial state. The kind of allowance condition, and then the incrementing step. In this case, decrementing. Let's call it the iteration step, the iterating step. Okay. Should get my vocabulary down better. So yeah, that's pretty much for loops. How are we doing on time? Ooh, we're doing really good.
There is nothing we can use. You don't go to a website or something.
Say that one more time?
It's just folder. There is nothing we can use if you log on to the company's website and you have the information.
Case is on GitHub website. You can go there. Do you also upload your source to GitHub?
Yeah.
You can go to his GitHub website and you can download the source code.
What I'm asking is there a way we can see how this is used in real life?
Real life.
So so for loop is often used when you just need to do something a bunch of times. At least this version of for loop. There's another version of for loop that I'm going to show you in a second. Yeah, we should have time for that. But yeah, normally you use this version of it just when you need to do something some number of times. Like, let's say I wrote some sort of web app, right? I have some website that I'm running, and I need to test it with 10 users. I might use a for loop to generate my 10 users and then run the tests, right? Anytime you need to do something some number of times is what a for loop is most often used for. It's not only what it's used for, but it's the most common case. Correct. A loop is meant for repetition. Now you can also, actually we'll do that next. I'm not gonna spoil anything. Also a message. Other examples might be, no, never mind. That's something I'm gonna show you next. So, does that answer your question?
Yeah.
Cool. Any others? No? Yes? No? Okay. Yes.
How many lessons
I was supposed to figure that out last time. So maybe I'll take the last 10 minutes and figure that out. Yeah, because the way we were going to do it is we're going to do kind of a beginner section, and then kind of an intermediate section, and then an advanced. And what I was really hoping was that once we finished the beginner section, maybe someone else would teach the beginner section, and then we could move on into an advanced section. But I have to figure out where we're drawing those lines. I'll figure that out at the end. So I apologize, I did not do my homework. So yeah, sorry, I don't have an answer for you.
how to do Java, one study for 2 hours, after I can do my own website.
Your own website.
Website. Then you should use JavaScript. JavaScript.
Yes. So Java and JavaScript are 2 different languages.
So, after running this function, you wrote it, like, you can activity.
Correct. So you can make a web server that will serve a website, which, yes.
So, guys, you can make your own website, but it's like 2 different areas. The front side and back side.
This is the back.
For the back end.
Yes.
So, like,
If you want to, this is more like communicate with the database. So what you call it, the Java, but if you want to,
It is not absolutely necessary. No. Now, the nice part is that the concepts between the 2 languages are very similar. It's just like a for loop in JavaScript. That's now JavaScript. Well, except for this part. Like, forget this part. That's not valid at all. But they're similar.
yeah, for basic level, it's over similar to each other. If you go to the best level, different from the basic levels,
Yeah.
it goes the same.
So if you were to go to the JavaScript meetup on Monday, you would be like, oh, okay, that's the difference. I get it. It's not. It would be easy. Second. Okay. And we can talk afterwards to figure out stuff. So we, crap. Sorry, I'm thinking for a second. We're probably not going to cover arrays and for in 18 minutes. Probably not. Yeah, I don't think so. Okay.
Also already headache.
Yeah. Huh?
Already headache starts.
Yeah.
And we're gonna change the time also, right?
Yes.
We don't wanna spend our money each time it goes this.
Right, right. Okay, cool. So then let's recap real quick. So today we covered conditions, we covered if statements, if else and else, or if, else if and else. We covered switch case and fall through and default and break, and we covered loops. We covered while loops, which is while condition is true, keep running this thing. And then we covered for loops, which is initialization step, allowing condition, and iteration step. And that's pretty much it. Does anyone have any questions about anything we did today? Yes. Yes. Yeah, Java is absolutely free.
Not exactly, but almost.
Because some companies are
Oh, no. That's not a thing. Yeah.
Can you explain one more time about the Boolean?
Boolean. So remember last week I explained several data types. You have your integer data type, which is a whole number. You have your float data type, which is a decimal number. You have, I should add that too. You have your string data type, which is text, basically. Boolean is another kind of data type, and it's either true or false. And that's it. That's all that a Boolean is. Now, a Boolean is used anytime where there's a condition.
So if the true, not true, false, it all belong to the Boolean.
Yes. Yeah. True and false are the two Boolean values. Just like for is an integer value. Does that answer your question? Other questions? Cool. So let's get into, we have 15 minutes left. Let's get into some housekeeping stuff. And I'm going to stop the recording because that is the lesson.